Good evening, guys. So this is our second class of failover. So in last class we just had configuration of the failover. So today I'm going to continue with the same configuration, and we will discuss today about the failover cases, like how we can do the failover, okay, and how the device is sending the packets, okay, and when device will do failover or when it will not do the failover process, okay. So we have access of the devices. So let me start. Okay. So if I'm going to check on the routers, so router have already configuration and the root, if you remember. So IP interface brief, we have IP, and even if we have here routing protocol, if you remember, we configured the EIGRP in the last section. So EIGRP is here. And similar on R2, we did configuration of telnet, SH, and HTTP, and even we have IP on the interface, right? And R2 have default route to reach to your firewall, okay? So I'm starting from the scratch on firewall. So the first thing we need to give the host name, okay? After that, we will configure here interface, that is each interface, no shutdown, IP address. Before that, give name to it, name if inside, IP address that have 10.10.10/24, okay? And we will give here the standby IP also, that is 10.11, right? And second interface is it's one, which is the outside interface, outside IP address 20.1.10/24, and standby is 20.1.1.11, right? So we did configuration on both interfaces, and now I'm starting with the failover configuration, okay? So by default is, if you remember, the failover is not on. By default the unit is standby and there is no configuration for that. So just do the failover LAN unit primary. So I'm making the ASA1 as primary unit. Failover interface, wait a minute, we need to define the LAN interface. I need to give the name can be anything, okay? That is my interface number 3, okay? So it will remove all the configuration if there is anything on it. After that, failover interface, and we need to configure here IP address. And what is the IP address? IP address on FA interface, guys, and here is 30.10, and mask is this, okay? And we need to give the standby IP also, that is 30.11. So we configured here. So if you check now, show failover, in this you will see the failover is still off, but we have now unit as primary. We configured the interface 3 as the FA interface, failover interface, but I forget to no shut down the interface. So before going to enable failover on the box, you need to make sure that device interface is no shutdown, okay? So it can make the connection and exchange the routes and sync the configuration as well. Now if we check again, so we have here now interface up, okay? So similar, if you check, we have here IP address on these interface 10.10, 20.10, and this is the failover interface. Similar, I'm going to configure on ASA2, and ASA2 interface. First of all, give the name, host name is ASA2, and we have interface, it's 0, the LAN interface, that is not required. If you remember, we just need to configure here directly the interface, which is the failover interface, okay? Now shut down it. Now configure failover LAN unit, okay? Just not required this. We need to configure interface is FA, and interface number 3, okay? Now failover interface IP FA, and configure the IP here 30.1.1.10/24, standby have 30.1.1.11. So I configured this information here, okay? And now if you check, failover interface is also up here, and see, and this is the secondary unit, right? And now we need to enable the failover. Before that, just try to ping 10. So it's able to ping. If you check show interface IP brief, so this is the unit secondary, you can see secondary, and we have configured this information here. We configured this IP on primary and this IP on secondary 30.11, right? And automatically device know this unit is secondary, so it have IP address 30.11. It have IP of 30.11, okay? And now after that I can configure here failover. Uh, yeah, good evening. On, yeah, I started with the direct command. If you check show failover, so I configured this is the first command in failover, right? I configured the interface and then IP. So I have not configured any as a secondary unit. What is the reason? If you check by default, unit is secondary. By default, the unit is secondary in failover. See, if your failover is off by default, at that time unit is also secondary. So ASA1 was also secondary for the first time. You can see where we just started. Check here. So when I did show failover on first firewall, so failover was off and the unit was secondary. So I make ASA1 as primary unit. Okay. And this is the command failover LAN unit primary, or you can make a secondary by yourself. Okay. But if unit is by default secondary on ASA2, I no need to define it because this is secondary by default. Okay, this is the reason. So I, yeah, so ASA1 is primary and ASA2 is by default secondary. So I no need to define by myself with the command. Okay. So now both are able to ping over the failover links. So, and one more thing, I forget to configure here failover link, that is FA is 3. So this command is for state link configuration, right? Okay, so that is only required on your, even I can configure on secondary failover link FA H3. Okay, and now I can configure the failover. So I'm going to on the failover on device. So I need to run this command. Okay, so wait a minute, and if you check show failover, so this is going to become, now see the failover is on, and if we have, see, failover is on, this is primary, this is the interface. Okay, and now similar I need to enable here. So now this is going to become the secondary unit. Why? Sorry, the standby unit. Why? Because it detects the active unit. Active unit is ASA1. Okay, so ASA2 is going to become the standby unit in that case. And let me show you the complete output, guys. Here the command is show failover. So this command will show you the failover is on the device and the unit is primary, and failover LAN interfaces name is FA. It can be anything. Okay, during the configuration you can set any name. The interface is 3, which is up, and the frequency of the keep alive packet is 1 on this failover link, and the hold timer is 15. Okay, and now we can see this is the primary unit which is active, and we have two interfaces, that is 10.10 and 20.10, and you can see the both are showing as unknown. Why? Because the still configuration is, I guess, not synced between the devices, because it will maybe take some time, and that's why those are visible as waiting. Okay, and you can see the secondary unit is block sync, and let me check. Okay, now we have enabled. If you check show failover, so this time see the secondary unit is standby ready, primary is this one, primary is active actually, and the secondary is the standby. And interfaces are visible as normal. Normal means now they are receiving the traffic and they are monitored, okay? And similar, if you check the output again, just let me check again the output. So this time interfaces are visible normal, okay, for active and for the standby as well. So this is configuration of the this output is showing the failover link output, and after that if you see we have now logical update statics as well from the stateful failover link. Why? Because we configured stateful failover link between the firewalls, so that will exchange the information, commands, connection table, escalate table, VPN, and the route information, right? So we are using the same link as our state link, and you can see we have sync of command is 14, so 14 commands are synced between them, okay? And after that you can see we have still no TCP and UDP connection, there is no ARP table entry, okay? And there is nothing like VPN because we are not using VPN. And even you see there is no route session, nothing else. Why? Because still there is no traffic movement on the firewall, right? So now I will do some more commands just to prompt state, and I will show the host name, okay? And after host name we will show the priority, okay? So just we want to see this is ASA1 and primary. And if we see on this one, that must be synced. You can see this is the standby and secondary, right? Now I'm going to configure routing protocol, because in last class, if you remember what we did, we enabled the AIGRP routing protocol, and here we have a default route. So okay, come on, what's wrong with it? So we configured here one. Just to give me a minute. It's misbehaving. Okay, so on firewall we are going to be configure here default route, so it can reach to the internet, right? So here is the internet, this is the internet, and that default route we are going to be advertised in our domain. So domain is using EIGRP routing protocol, so I will enable EIGRP here and redistribute this default route into the EIGRP, and that configuration is going to be sync on your firewall, okay? So let's do that. So we are on firewall 1, so I'm going to be configure route first outside, and the route is default, and the next stop is R2, okay? And now I'm moving into the EIGRP routing protocol, and I'm using the network command for the LAN network, and then redistribute static route inside it, right? And now if you check show run EIGRP, so we did here router EIGRP configuration and advertise the static route, so that configuration also replicate to the ASA2 through the failover link. If you check, it must visible here, okay? So configuration is visible here, but if you check we have here neighborship, show EIGRP neighbor. So neighborship is always visible on your active unit, not on the standby unit, okay? But you can see the routes here via EIGRP because we configured two loopbacks behind the R1, okay? Those are coming. But similar, if you check on this show route, so routes are visible here. That is not the problem, right? Route will be visible because routes are also exchanged through the failover link, okay? But show EIGRP neighbor. Neighborship is only found by the active unit, not by the standby unit, okay? But a standby unit will get the routing information update in the routing table, okay? And if you check show EIGRP topology table. So in topology table, it will not receive these routes. Those are coming through EIGRP from another neighbor. But you have just like a redistributed route by the same firewall only and the LAN network, okay? But the same thing if you check the EIGRP database on the primary unit, which have neighborship. So which unit have neighborship, that unit have all the routes of neighbor as well. Because see, try to understand. Now, so this router have neighborship with firewall 1, right? So whenever this router have any prefix, so this is sending EIGRP update packet to this one. Okay, so EIGRP updates are coming on the active unit only. So active unit is going to be maintain the topology table of EIGRP, right? And then going to be installed into the routing table. Okay, so now this unit, the active unit is sharing the routes with the standby unit. So standby unit is only receiving the route. Okay, only receiving the route. But if you talk about EIGRP neighborship, EIGRP neighborship is not going to be from this unit. And even if you check the topology table database, if there is no neighborship, so route will not visible in the topology table as well. Route will only visible in the routing table, and that is through the failover link. That is through the, you can say that is because of state link, guys. Okay, that is through the state link. If you see, let me show you the output. Okay, so what we need to do, show failover. So in failover, see, okay, everything is good. This is the primary unit, and they are trying to sync, like they have sync 85 commands, okay? And ARP have here entry. So ARP entry is also exchange. That is only maybe your, if you check, show ARP. Right now we have here this entry 10.10.1, okay? And that entry must be visible here also because we have exchanged or we have configured the state link. So state link is exchanging this information also through the uh, state link. The active unit is sharing the information with standby through the state link, okay? And after that you have two route sessions, those are through the EIGRP, okay? Still there is no traffic flow, so that's why there is no TCP UDP connection, okay? And now you have user identity also, so those informations are exchanged through the state link. So that's why we need both type of link here, okay? If you check the document, wait a minute. Okay guys, so we are just discussing about the failover and the state link, right? So we configured the failover, okay? And in that failover, as we know, this unit is our active and this is the standby. And we are using here just one interface, and we have one layer to switch as well between them. That is our failover link and also state link, right? So just try to understand what is the benefit of failover link and what is the benefit of state link, and what failover link is going to exchange the information between the firewalls and what information state link will exchange, right? So this is the main concern. And here we can see this is the overview which we already discussed about that. And the second part is you must know the hardware and the software requirement. So hardware requirement we already covered, like if you are trying to form the failover between the devices, what is the requirement? Okay, so for hardware both must be same model device, okay? The series must be same, like 5500X, whatever series you are using, or the higher series. And the interface number and interface type must be same, like if I'm using H0, so the second firewall also have same. it never have like gig interface. Okay, that should not be work. And after that, if we have any module installed, like if I have IPS module on the firewall or any additional module to just to make it like FTD, okay, so that must be same. And even we have same RAM size installed, okay, and after that just read it. If you have additional memory flash size, that must be same, because there can be any failure because of smaller memory size, okay. And in software requirement, the first of all, firewall mode must be same. It can be routed mode or transparent mode. Second, the context must be same, like single context and multi-context. By default, we have single context, right? But you can use multi-context if you want to use in active failover. What do you want to use, guys? Active failover on the device. Okay. And the rest of thing is here. Okay. And the third point is about the operating system. So you must have same major and minor version of the software on the device. And the last thing is about if you have any connect image on the firewall, like if we are using remote access VPN, so that is going to be connect with your firewall. If firewall is into failover, so both must have same image, okay? And both must have same any connect profile as well, okay? After that, there is some license requirement. If you are purchasing so 2 unit in the failover configuration, don't need any identical license. The license combined to make a failover cluster license. Okay, so that how you can check like in your base license, uh, failover is included or not. Okay, so you must check before procure the device and the license. After that, we have two major thing here. The first one is the failover link for me, and the second is stateful failover link. Okay, what is the failover link, guys? The failover link and the optional stateful link are dedicated connection between 2 units. So we have like these two uh, links for different purpose. So you can read this one. All information sent over the failover and the state link is in clear text until we secure the communication between the IPsec tunnel or a failover key. So by default, like if just make a normal failover and state link between the firewalls, so that must be in clear text instead of your uh, encrypted data, because we have to make IPsec tunnel otherwise, or we have to define the some keys. Okay. And ASA is used to terminate VPN tunnels. This information include any username, password, or pre-share key used to establish the tunnel. So you can form such tunnel between the firewall also just for more secure communication. And we have failover link. So failover link exchange this type of information. See, so this is the data that is exchanged through the failover, and what type of data it's used to exchange the information. So following information is communicated over the failover link. So they exchange about the unit status. So that means if we have here firewall, so this is my firewall 1 connected with the failover link to my firewall 2. So the first of all, they are exchanging about the status. I'm the active unit, I'm the standby unit. So if this is your active unit and this is standby unit, so whenever they are sending here keep live, so they are exchanging about it. I'm active, I'm the standby unit. Okay, and they are sending hello message. Those are actually keep live messages after every 1 second from that link. Okay, and this share network link status, like status of this link also, my link is up or down. Maybe you have here some layer 2 device, so they are exchanging information of that link also, and other data interface, those are for inside or outside network. And they exchange the MAC address. Actually this MAC address is not the end user MAC address. This MAC address is interface of the firewall. Okay, interface of firewall. So those information are exchanged. And the next, configuration replication and synchronization. Configuration replication synchronization means whatever configuration you are going to do on firewall 1, the active unit, so same configuration this failover link will replicate on this one, same configuration. But we will see what configuration they will not replicate. We have to be make sure about that. We have to maybe do manually, okay, or maybe we have to do avoid that or not, right? Okay, so these are the things that are exchanged through the failover link. I hope there is no doubt, guys. Is it clear to everyone? Okay, so this is the data which is exchanged over the failover link. Okay, so if you have any doubt, just go through the document. Okay, you will get done. So, and the next, what failover link do actually? Okay, or how we can configure it. See, interface for failover link, we can use any unused interface, physical, redundant, or ether channel as failover link, and you can't specify interface that is currently configured with the name. So that should not be configured with name or IP. Okay. Failover link interface is not configured as normal networking interface. It exists for failover communication only. That means if I choose any interface, like we choose here interface number 3, so 3 interface don't have any configuration, then we can use it, right? After that, how we can connect it? So the first of all, we can connect it using a switch with no other device on the same network segment, broadcast domain or VLAN. That means you can simply use here like firewall, a dedicated switch for it, and here also the firewall too, right? So that how you can connect it without with no other device on the same broadcast domain. So if you have maybe other device, so make sure that device is not part of the same VLAN. That means like I have one here router, right? Okay, and one router also here. So this must be like part of VLAN 10 and VLAN 10, and this is part of VLAN 20 and VLAN 20. So you have single broadcast domain just to make communication between the firewalls on the failover link. Okay, so they just want dedicated broadcast domain or VLAN for that. Okay, but this should not be shared. Shared means if I have here firewall connecting with a switch, and here also firewall too, and we have two more devices, so those cannot be part of same VLAN on this switch. Same VLAN means they have now like broadcast domain same, so they can send data to firewall interface as well, like ARC request or something. Okay, after that we have an Ethernet cable to connect the unit directly without need an external switch. So the second option, you can just connect them directly also. So normally we connect directly, we don't use any intermediates device. That is not even recommended, okay? But if you don't have a switch between the unit, if the interfaces fail, link is bowed down on both peers, and this condition may hamper troubleshooting effort because you can't easily determine which unit have failed the interface, cause the link came to down. Okay, there is one thing. Okay, let me read the second paragraph as well. ASA support auto MDI, MDX on copper Ethernet port. So you can either use a crossover cable or straight cable. You can use straight through cable interface automatically detect the. Okay, that is other thing. Let me try to explain what they are trying to explain with this paragraph. So that means this is one firewall, and here we have second firewall. So if I connect directly this cable, so if the port is down because of this side firewall, okay, so this entire link is going to be down, right? And in that case, the firewall 2 cannot determine this problem is on my end or this problem is from other firewall. So they will not check this thing actually. So if I connect between them in layer to device, so if because of firewall 1 this link is down, so that link will be down on switch end now, okay? But here this link remain up on firewall 2 and the switch. So in that case it will be more easy for firewall 2 to check where link failover happens, on firewall 1 on me. So it will check my port is up and I'm sending here keep alives, 3 continuous keep alives, okay? So in that case, it will generate 3 continuous keep alives if this link is down. And in these three keep lives, if there is no hello packet from firewall one end, so it will send now LAN test packets from this link also and on LAN interface also, just to make sure that device is up or not. If the device is not up, it will not give you any reply even from the data interface, even from the data interface, right? If device is up, it will give reply from the data interface if this link is down because of any reason. Okay, we will see this scenario, but just for now, this point is clear to everyone. Why switch is required? Because it will give you more accuracy. Where is the failover happen, on this firewall or on this firewall, right? So you have here some layer 2 device in that case. So it will make sure this is separate segment and this is separate segment uh, for physical connectivity. Okay. So this is about the failover link connectivity and what failover links share the information. Okay. Normally we are using now even fiber ports. Okay, just for failover link, but even you can use the Ethernet cable. So you have one auto protocol which help to sync the cable if you have straight cable or crossover cable. Okay, doesn't matter. And after that we have stateful failover link. So that means to use stateful failover link, you must configure a stateful failover link, okay, to pass the connection state information. That means they are talking about here state link, guys. They are talking about state link, okay. Like what state link do? So the first thing, they are giving you dedicated interface recommendation. So that means you must use two different ports. I am using here right now one port, but you can configure two ports. Like we have firewall 1 and firewall 2. So I must connect two port here, okay. And in that case, the one port is as my failover port and the second is state link, okay. So that's what I can use. So if there is any problem with this link, at least this link can share the like connection table, VPN information, escalate table information, right? So this is the main reason. So you can use a dedicated physical interface, or it can be like port channel for the state link. Connect dedicated state link in one of the following two ways. So there are two ways they are giving us. The first one is the same. We can use a switch between them like this. So through switch you can use, okay, but make sure there should be no any other device in the same VLAN or in the broadcast domain. And the second, we can use Ethernet cable directly to the appliance without using the switch. So second option is you can use directly cable. That is the second option. And if you don't use a switch between the unit, the link fails. Okay, the thing is same here also. You will not get the idea where is the problem. Okay, where is the problem? I hope this is clear to everyone. Now, okay, so the same thing is here, okay, and there is one more thing that is additional on that link. For optimized performance when using long distance failover, the latency for the failover link should be less than 10 milliseconds or more than 250 milliseconds. Okay, so this should be the latency over the link. So accordingly, you have to be use the length of the cable. Okay, if latency is more than 10 millisecond and some performance degradation occur due to retransmission of the failover message, so there can be problem. So you have to make sure about that. And after that, the shared with the failover link. So now this is the second point. The second point is saying share a failover link might be necessary if you don't have enough interfaces. If you use failover link as the state link, you should use the fastest Ethernet interface available. So that means in our case, we are using this situation. And what is the situation? We are using single interface between them for both purpose, for failover plus state. So make sure this must be your fastest interface. Fastest means like I can use 1 gig interface with fiber port, right? Fiber cable. So that is the fastest for me. So one interface can be used for both purpose. Okay. And after that, shared with the regular data interface, that is not recommended. We never use that. Okay. So sharing a data interface with the same state link can leave you vulnerable to replay attack. Okay. So we have to avoid that. So data interface we can't use as a failover link. Okay. And after that, okay, these are the avoiding interruption failover data. Okay. And wait. I'm just trying to check where is the information about the failover link. State link actually. Okay, there is one is stateless failover and one is stateful failover. So guys, if you remember stateless failover, we have already shown that. Okay, but let's read it again. When a failover occur, all active connections are dropped. Client need to reestablish connection when new active unit takes over. What is the meaning of this line? Any one of you can explain me? I will show you this behavior here. Guys, what is the stateless failover and what is the stateful failover? Just put into the comment box. So guys, now to understand the stateless failover and stateful failover, first of all, we need to do the failover. We need to do the failover. So right now we have configured the failover link, which is h3, and I configured the state link, which is also h3 for me because I'm using the shared interface. Okay, but this is dedicated only for these two purpose. Now, as you know, failover is just exchange the configuration part and these things, but state link exchange the escalate and all these things, right? So I'm going to remove the state link information first. Okay, so I'm on the primary unit. So if you check show failover, in show failover you can see the state link is configured, and I'm going to remove it, guys. No failover link fa, I removed it. Okay, and just let me check show failover. So see, we have just here now failover link. We don't have any state link. State link is unconfigured, right? So this must be visible on my second firewall as well. Yeah, because configuration is replicated through the failover link, right? So that means now we have just replication of configuration. We don't have replication of a connection table, escalate table. So right now I'm initiating here traffic. Okay, I'm initiating the traffic. So for that, I'm going to make the telnet connection with 20.1.1.2. So in that case, you can see telnet connection is done, guys. Actually, yeah, this is telnet connection, but maybe if there is any lag, it will again form the connection. We will not see that type of drop here, but I will just try to make, okay, the situation. So what I'm trying to do, when failover will happen? The first question is when failover will happen. So what is the situation? So the first thing, if you say if this link goes down, will be there any failover? Will be there any failover? Okay. So if failover link is goes down, that will not make any failover. Failover link is just to share the information or sync the information between the device. Okay. Actual failover is when your firewall is down completely. or if firewall is not down, if your data interfaces are down at that time, device will do the failover. So first of all, I'm going to just, okay, just let me do one thing. Uh, I'm on firewall 1, capture ABC interface FA. So I just try to capture this interface. Wait a minute. After that, do we have some specific match, fifth tuple, packet length, real time trace? Uh, okay, don't match it, just capture it. Now just try to check show capture ABC. Okay, so just see, we tried to capture this packet. So it just giving me 120 packet down here. So see, uh, if I start from the first one, so see here we have this packet in which 30.11 is our standby firewall sending packet to this one on protocol number 105. So 105 is the protocol which we discussed yesterday, SCPS. SCPS is the protocol. If you just check, let me try to capture the packet. If that works, let me check. Abandoned connection, why? Okay, just a minute. SSH connection. Okay, just I log in the EVNG. Okay, so if I'm trying to capture again, let me see now we are getting the error or not, because it it's not able to make connection with the with EVNG. So just I take SSH of EVNG so it can make smooth connection, right? So now I have here packet capture, and if you see in packet capture they are sending with this protocol SCPS, right? And if I log in and we have here data, so data is not visible actually, but this is the traffic they are sending, right? So the protocol is, this is the destination, this is the source, and protocol number is this SCPS. Because actual information is not even visible to me. Just let me try. The only data is visible like this. Okay, so maybe that is some kind of data. The data is 70 bytes. Okay, so because these are the keep live packets, and if I do any configuration, let me send some configuration on the firewall, like we did interface it 1 and 2, right? No shutdown, show interface IP brief. So we have no shutdown interface here also, and here also, right? So wait a minute, must be, data size. Actually, data is not visible. Maybe that how data visible actually. Okay, maybe that is the real data that a device understand here. But just we try to put, okay. So you can see the traffic is exchanging through with this protocol. Okay, on protocol number is 105. And now we captured the packet and we are able to see the traffic, right? So traffic is moving on the interfaces. So now in that case, if I'm going to shut down the interface on my switch interface, so I will down the switch interface, it's 0 by 0, which is connected with my primary firewall. So just log into the switch number 3. Okay, just give it to name switch 3. Okay, and we have to down the interface. It's 0 by 0. Okay, so interface is down now. So let's see on the firewall. Show failover. Actually, yeah, I down the interface, and we have now see here is connection. So connection is still here because failover is not happened. You can see there is failover LAN interface is failed, but still there is no switch over. Why? Because still interfaces are working. Interfaces are working. So if I do show failover, the output is visible here. Okay, see the interface is failed, but still there is no switch over. That means still your ASA1 is the primary. Okay, and if we see the physical interfaces are also visible as normal and monitored, there is no problem, right? Okay, and similar on this, the failover LAN interface is failed, but still there is no switchover, and show failover. So that means if there is any problem with the interface, see the interface is up on this one. If you see, interface is up here. Sorry, interface is failed. Failed means they are not able to exchange packet from here. There is no, still no switchover, right? But no, because normal data interfaces are still working. But you can see these interfaces are visible as unknown because of the failover link is down. Okay, and similar, wait a minute. Yeah, here it's visible. Okay, but let me check again on the this one. Yeah, these are visible as unknown, maybe because of this failover of the link, right? That's why not visible. And now let me make it again no shutdown on the switch, the interface. So you can see the traffic is still going on. And if you see the connection table is on the show con long. So we have still connection here, right? We have still connection. And actually we are not using net, so let me configure the net, but that will be not synchronized, right? That will be not synchronized. So if you have a problem with the failover link, and if you configure anything here, okay, let me try to configure, and I'm using net inside, outside, dynamic interface. So I did here configuration. So if you check show net, here we have net configuration, and traffic is still going through it. And let me disconnect it and make the connection again. Admin and Cisco. So what I did, I configured pat on firewall 1, which is the active one, and I try to initiate traffic again. So that must be through the pat. That must be through the pat, right? Because you can see the pat is configured here. But this configuration will not replicate on the standby firewall. Why? Because the link is down. See, there is no net. There is no configuration of net, right? But we have here net configuration on primary. Okay. So in that case, if you check show escalate table, so the device is going to be netted, right? The IP address is going to be through pat. So that means the firewall is translating the IP. And now again I'm going to no shut down the interface and wait. Last time I don't did no shutdown. Okay, if you remember, now link is no shut, and see now. Okay, show failover. See, the both the interfaces are normal and normal here. Wait a minute, the switch will take actually some time, so just switch port host. Okay, so just to make the port quick. See, failover line become okay, switch over, enabled, configure, change, replicate to mate. So it just did the configuration on mate as well. And show failover now. So just I did here switch port host command on the switch. Why? Because just to make the configuration first. Okay, because by default spanning tree take 30 seconds, so just I skip that task from switch. And now port is up, and you can check on this one, switch over configuration replicated. Okay, and if you check now, NAT is here, but still we don't have connection table. Why? Because this is the stateless. This is the stateless. So now this is like part of failover. So still failover is not happened, and we have not seen the stateless behavior here. So just what I'm trying to do now, I'm going to shut down the LAN port. I'm going to shut down the LAN port, and still you can see R1 is still in SSI telnet connection, right, with R2. So let me down the port and we will see interface it's 0 shut down. So I did the down LAN port. See, wait a minute. Why primary still active? Just a minute. We did the interface. Actually, my bad, my bad. What I did, I shut down the port on firewall. If you down the port on firewall, so like this is my configuration on firewall, and configuration is replicated here. So I have to shut down from the switch end. Okay. So this is the stupid idea. Just let correct it. Okay. And show failover. And the port is now normal. It's waiting just to move in the monitoring. It's waiting because of the switch ports are not fast on the switch one. Just log in the switch one. Okay. And now wait. Yeah, now ports are normal. So now I have to down the port on switch actually, not on the firewall if I want to see the failover behavior. So, okay, here we are on R2. Yeah, so we have just we are on R1, but host name is R2 because we have telnet connection here. And now I'm going on switch one just to down the interface. It's 0 by 0 connected with firewall 1 interface LAN. Okay. And now see, port is moving into the testing, and see the switching to standby. So this is moving to the standby. Why? Because now there is failover, the LAN port is down. We have not down on the firewall, we have down to the switch. So you have to down on the switch. Okay. And if you see, the link is failed. Why? Because the port is not up. And see, the primary is showing as the failed, even not as the standby. Standby is the only when all the ports are up, because one port is down here. That's why it's showing as failed. Okay, failed means the appliance is failed to fulfill the requirement of the standby. If I no shut down this interface, then it will show as up. Okay. Now, so failover means, that means the device is not capable to become the standby, because the standby have requirement interface must be in the normal. Okay, not into the failed. Failed means like the link is failed because on the other end the port is down, right? Or there is any failure in the physical connectivity. So now this primary appliance is failed and secondary is visible as your active, and the ports are normal here. And even you see the IP also switched. Those IP were visible on primary. Now those are switched here, right? You can see. Okay. But still your that entry still exists here. Okay. And show con. So you can see the con entry is not here. And accordingly R1 lost the telnet connection. R1 lost the telnet connection. So that means if you forget to configure state link and during that there is failover, so it will not replicate the connection table and escalate table. So that means the user will experience the network breakdown. Network breakdown. So I hope this is clear to everyone now. What is the stateless condition here? Stateless condition means the link is up, but the link is only failover link here. Okay, we have not configured the state link. If state link is not exist here, and if you have failover in the network, so that traffic was passing through it after pat. Okay, and you have entering the connection table, so those information will not replicate here in connection table and accelerate table. So the same user will disconnect here with the remote device. So this is condition of stateless. Stateless means you are not exchanging the connection table and escalate table with the standby device. So whenever standby device is going to become the active, it will drop all the traffic which is part of the previous connection through the active unit. Okay, so device have to reinitiate to make the connection again. Okay, you can see connection is failed. So when we were in R2, I tried to enter and we failed because the connection is dropped. Because the connection is dropped. Okay. So what we have to do? Just we have to make the, let me know, shut down the interface again. But in this time, primary will not become as your active automatically. Why? Because active is already exist in the network. So primary can't become active. Okay. Primary will become standby in that case now. See, ASA1 primary, but this is visible as a secondary. Okay, and just show failover. You can see now this is the standby and the link is up. That's why it's showing as the normal device, normal interface. And the secondary is active. Okay, so now on secondary, I will configure failover link and the link number 3. Okay, so it will exchange the information. Okay, like the routes. Okay, and even if I'm going to make here any connection, let me show you the talent connection again, admin and Cisco. So those connection must exchange with primary, or you can just standby. So you can see we have now here two ARP table, one TCP connection, and escalate table entry will not visible here, just showing you the timeout. Okay, so our device have now connection. See the connection log entry and show escalate. So these entries we are able to see on the active firewall, which is my secondary. Okay, so those must be replicated through the state link to ASA1. And now we can see show. Okay, are we getting? We have ARP. Okay, the command. Wait a minute, why the TCP UDP session is not visible here. Show con. Okay, entry is visible here. Show escalate entry is also visible here. So entry is visible here, guys. Okay, and now okay, it's working. So I will do manual failover, and I can do failover active. I will make this as active. So this is now going to become active with this command. I can make it manual active. Okay, see, from standby to active, and show failover, and see, primary is again active and secondary is the standby still. But see, there is no problem with traffic now. See, still we have connection with R2. So that how you can make sure there is no problem with this. connectivity. Okay, so this is the difference between stateless and stateful connection. I hope this is clear to everyone. Guys, is it clear? Okay, so the next what I'm going to do, I will telnet it on port number 80. So you can see my telnet connects HTTP connection is up. So what I did HTTP connection to R2. So in which active unit is firewall 1, and I will so just show con, in which we have here now this connection port number 80. Okay, that connection is visible. But is this connection visible here? No, you can see the con connection is not visible here. Why? What is the reason? Show failover. Okay, failover link is still here, but you can see we don't have entry. Why? If you check, we have entry for it because we delete this connection, so it will remove, and we have new connection is 80. So by default, HTTP connections will never replicate. HTTP connections will never replicate, so you have to do replication of HTTP this command. So you must run this command, otherwise your connection will not replicate. So I'm just going to delete it again and going to open the connection again, and now we will see show con, we have here connection. Okay, check on the firewall 2. Now we have connection here. So for some type of traffic, we need to make sure the replication will done by default or not. Like by default it will do for other protocols, not for HTTP. So we have to do for HTTP. Okay, and if you check the document, so you can see the features. If I do the stateful failover, when stateful failover is enabled, active unit continuously passes per connection state information to the standby unit also. Okay, so during the failover, standby unit have all the connections, so it will not drop the connection. So these are the supported features for the stateful, like net table will exchange TCP UDP ARC layer to bridge table. Okay, HTTP connection will also, but we have to replicate it. See, if HTTP replication is enabled only, by default ASA does not replicate HTTP session information which stateful failover is enabled. Okay, so you have to make sure about that. And ISA camp SA's IPsec SA also exchange GTP PDP connection, SIP traffic. Okay, ICMP connection, dynamic routing protocols, RIB information. Okay, like OSPF, EIGRP, those information. Cisco IP soft phone session. Okay, for call manager, that is like belong to collaboration voice part of. Okay, and VPN connections also. But which features are not supported? Like HTTP connection is not replicated by default, but we can do that. And user authentication table, okay, that is not replicated. Application inspection are subject to advanced TCP state tracking. Okay, so that is also not even. And DHCP server lease, okay, state information of the module like IPS, SSP, ASA, CX, SSP, phone proxy connections. So these things are not supported. So before using the failover, you have to make sure which type of configuration you want on your device. If one of them is not supporting, you must avoid this thing. Okay. So is that clear, guys, about this feature failover? Everyone? Hello?